Okay, so good afternoon, everyone, and welcome to the fourth Exchange Scheme Open Call webinar that is being promoted by the ENFIELD project. The session will be recorded, so if you do not like to be filmed, you can keep your camera off. Otherwise, please be aware that this webinar is being recorded to be made available afterwards also on the website and YouTube channel of the ENFIELD project. Today's agenda. I hope you all can see my screen. If not, please let me know. Today's agenda will follow the 4 points that you can see. We will be doing a brief introduction to the ENFIELD project. Then we will give the floor to the technical partners of the ENFIELD network to present the challenges that are currently being promoted within the open call. Then Innova will be navigating you through the process of applying to the open call, and then there will be room for questions and answers. Please, we ask all participants that have questions to use the Q&A feature in the webinar, and if possible, please add also the corresponding code of the challenge to which your proposal or question or query is related to. So, ENFIELD is a funded European project within Horizon Europe, and it aims at creating a unique European Centre of Excellence that excels the fundamental research in areas that are new, strategic, and of paramount importance to successful AI development, deployment, and acceptance in Europe. The ENFIELD project came as an answer to the topic launched by the Horizon Europe program focused on human-centered and ethical development of digital and industrial technologies. It started in September 2023. It is planned to be concluded by August next year, and it has received a total fund of around 11 million euros. It is set to establish a European Centre of Excellence for research efforts around AI, and intends also to reduce fragmentation, attract investment, and position Europe as a global AI leader in the areas that we are focusing. The fundamental research that are addressed by the ENFIELD project encompass adaptive, green, human-centric, and trustworthy AI, which are represented in the form of research pillars. Corresponding to those research pillars, we have 4 industrial domains, referring to industry sectors including energy, healthcare, manufacturing, and space. By conducting high-level research aligned with the challenges in the industry areas, ENFIELD aims to strengthen the European competitive position in AI and become a leader also in these domains. The consortium that is implementing the ENFIELD project and set the ground for the initial network around the ENFIELD environment is composed by 30 consortium members from 18 countries that include top-level education and research organizations, large-scale business, SMEs, and public sector representatives. The network is coordinated by NTNU from Norway. To reach the ambitious goals of ENFIELD, the project intends also to attract the best talents, technologies, and resources from world-class research and industry players by holding 6 open calls. 5 of them have already been launched. This will be our final open call. Open calls within ENFIELD are divided in exchange schemes and innovation schemes, and we aim to provide support to a total of 76 individual research to conduct foundational research activities and innovation schemes that intend to support at least 18 small-scale projects promoted by legal entities. As mentioned, in terms of the exchange scheme open call ENFIELD promoted for, this will be our last open call for exchange schemes. The other three have been already launched and closed, and the projects are currently ongoing in collaboration with the partners of the network. For the fourth exchange open call, that is the subject of this webinar, the network has been proposed 34 challenges divided by the research pillars and industrial domains, as you can see, but also presents three cross-collaboration challenges that are aligning one of the research pillars with one of the industrial domains. I will give now the floor to the technical partners of the network to present the challenges that are being proposed. And again, I would like to ask that in case you have any questions related to the challenges, please use the Q&A feature and include the code corresponding to the challenge that you are mentioning. We will start by exploring the challenges regarding green AI, and therefore I give the floor to Sagar Sen from Sintef.
Thank you, Anna. Could you please go to the... So I can even start, like we have 4 challenges. 2 of them will be hosted at the No Center in Austria, and 2 of them will be hosted at Sintef in Norway, Oslo. So would you like to go? Can I go to the next slide myself? Yeah. The first challenge where we propose is that of this problem of searching through large databases of image and point cloud data. So we have data sets that are very large, and problem is the current methods for retrieving exactly what you want in this type of modality is very slow and requires high energy. So the idea is to somehow come up with a representation that is not that of raw data, but of scene graphs where we identify objects and their relationships that make it easier. So the goal would be to actually come up with a method to index the scene graphs and come up with comparisons with traditional approaches or approaches which involve heavier machine learning models to see what consumes more energy and what is the latency in terms of retrieval, exactly what we need, in addition to the performance of what we're looking for. Could you go to the next one, Anna? Yeah. So the next challenge we have is that of making energy efficient multi-agent AI, in particular for code generation tasks. So we have digital twins of physical systems that provide a lot of data in different modalities, mostly a lot of time series data from sensors and so on, can also be image data. So we want to generate code to query these digital twins to answer questions and do so in an energy efficient manner. So the code would essentially navigate the digital twin and obtain answers for you. So we want to use multi-agent AI to do this, but in a green manner. So, and in both the challenges, we have use cases in multiple sectors. In the energy domain, from smart meters, from LiDAR data of overhead power lines. So we have also image data from manufacturing, which includes electronic waste, and also high perspective imagery from satellites in the space sector. That's it from me, Anna. Thank you.
Thank you, Sagar. Bernard, do you wish
Yeah.
to speak about the other two challenges?
Only about the fourth one. I can say a few words there. I did prepare a slide because I wanted to keep it very short. Physics for machine learning is a very popular topic these days, and there are claims that physics and machine learning are green. The main idea behind that is that the machine learning models incorporate prior physical knowledge, and this should improve the inherent trade-offs between model complexity, training requirements, and model performance. Now, these claims have been put out there a lot, and they make intuitive sense. But I think what is still missing is experimental validation of these claims, and that is what this challenge focuses on. This challenge focuses on finding out on a concrete use case, because the physics for machine learning comes in many flavors. So on a concrete use case, preferably from the energy domain, it focuses on understanding what are the actual trade-offs that can be improved according by incorporating prior physical knowledge. So in other words, is physics for machine learning really green, or what do we lose when we want to have it green in terms of performance? Yeah, that would be a brief summary of my challenge. Since I have to leave for another meeting quite soon, I would appreciate if you put a question to the chat, and I will try to be back at the Q&A session, which will happen in half an hour or so, I guess.
Okay, thank you, Bernard.
Thank you.
I would like to ask if we have the representatives from Politecnica Bucharest or TUE in the call. Otherwise, I will move forward first to the Trustworthy AI pillar. Okay, and then we'll get back to the human-centric. Okay, trustworthy. Trustworthy AI is led by NTNU. So, Georgios.
Yep. Hello.
Hello.
Hello, everyone. So here we have quite a lot topics, as you can see. So the idea behind this is that we start with the three topics that are quite the three challenges that are quite general and with wide scope, as you can see. So in the first one, the security and robustness of AI system, we try to deal with general aspects regarding this. We have privacy and compliance of AI systems and AI in distributed systems. So in these challenges, the applicants are able to deal with general research proposals in several domains, such as security, privacy, compliance, trust, distributed AI systems. So having the opportunity to explore aspects such as adversarial machine learning, for example, potential defenses techniques against adversarial attacks, or how we can use federated learning to enhance privacy, and so on and so forth. So these three are the general challenges that are quite open to research proposals. Then we move on to more detailed, let's say, challenges, which are the next four challenges. So in this one, we are actually dealing with aspects regarding enhancing user trust in AI-powered chatbots using UBM. UBM is the user behavior modeling. So this topic, actually, this challenge try to deal with the aspect that AI-powered chatbots are on the rise nowadays. So user trust in these systems remains a significant challenge. So this topic tries to deal with that aspect by fostering transparency, accuracy, emotional intelligence, and the responsiveness overall to the user behavior. So by leveraging this challenge, the applicants will be able to explore how we can integrate and how we can leverage user behavior modeling in order to enhance the trust that in AI-powered chatbots. Then moving on to the fifth challenge, here we have the title of the topic is the Trustworthy ML-based Scheduling for the Energy Domain. So nowadays, the challenge that this topic is about is that nowadays there is an increase application and utilization of AI for efficient resource allocation in power grids. So with this topic, ML-driven scheduling will be analyzed in order to see how we can leverage also digital twins of a production line, of a power grid, of an energy grid, to enhance the trustworthiness of such AI models that are used for the scheduling. So aspects such as realistic energy-aware constraints and adversarial perturbations are among the goals and aspects that will be explored in this topic. Then in the sixth, here we can find actually a few more details about this challenge. I don't know if the time allows it to go into detail, but in the sixth topic, we have a unified approach to assess safety and security of AI system. So actually here, both aspects of safety and security of AI will be explored to deal with incidents and hazards linked to safety of humans, systems, and infrastructure as well, considering together the cybersecurity threat. So although there are several tools that partially measuring safety and security properties in such domains, in this challenge, the candidate will try to propose a holistic approach to assess what we call a unique AI safety and security score based on the safety and security properties and measurements. So here in this slide, we can see the main research activities and the expected results of this challenge that focuses first of all to investigate existing and computable metrics related to AI safety and security properties, and to develop a methodology or a tool that will be able to assess what we said before, a unique score, AI safety and security score based on these properties. And the last topic challenge for the Trustworthy AI is the LLM safety and security. Again, here we see safety and security as an aspect. So the idea is that LLMs must be safe and secure. And why? To be able to avoid bias, misuse, adversarial attacks, and unsafe autonomous behavior. So there are several vulnerabilities that undermine trust in current systems, such as jailbreaks, multi-turn obfuscate attacks, and etc. So during this challenge, the candidate will be able to explore aspects such as adaptive defenses that evolve over extended dialogues, interoperability guided methods to detect unsafe behaviors, or domain-specific safety adaptations for critical sectors, including some of the sectors such as energy, healthcare, manufacturing space. Lightweight robustness and alignment techniques for resource-constrained deployments, continuous monitoring and self-healing modules for deployed systems, and system-level security frameworks deals with aspects such as proposing or analyzing existing frameworks or proposing an appropriate one for such domain. So yeah, this was the last challenge. So if you have any question, I would be more than happy to answer potential questions. Thank you very much.
Thank you, Georges. I will give now the microphone to Adam from IMT to present the challenges related with the adaptive AI research pillar.
Hello, everyone. Sorry for my voice, but I'll do my best to speak clearly. So there are 5 challenges in the adaptive AI pillar, most of them in relation with topics in applications in manufacturing. So the first one is related to enhanced visual understanding of inspection and maintenance, and this has to do with non-invasive fault detection with hyperspectral imaging, so both on public datasets and potentially private datasets. So here we seek to develop various, segmentation models, state-of-the-art segmentation models for this problem in a way that's easily adaptable across data sets. Next. Then the second one is efficient continual learning systems. This is a more fundamental topic and is very broad. So there are several things that could be explored here, from leveraging foundation models in continual learning in general, integrating parameter efficient fine-tuning, pursuing efficiency through architectural and algorithmic techniques, studying multimodality, developing new methodologies, incorporating hardware-aware optimization. So very broad. Here the applicants will be free to really define the topic that they really want in terms of continual learning systems. Next. The third topic is lifelong learning and fine-tuning in LLMs. So this focuses more specifically on continual fine-tuning of LLMs in particular. So here it's very broad as well. And so it can go from exploring continual pre-training and fine-tuning in LLMs and multimodal foundation models, designing new paradigms for fine-tuning and training, exploring reinforcement learning approaches, and comparing against benchmarks and metrics and so on. So fairly standard approach, and here again a lot of freedom on the applicants to define the topic. Next. The fourth topic is an applied one in manufacturing and has to do with the sorting of plastics using hyperspectral imagery. So this is on high-speed conveyor belts. So there is it's a task that's quite challenging in the sense that those go very fast and there's a lot of uncertainty depending on the plastics and the color. And so here we're interested in deploying, state-of-the-art AI approaches, but ideally in a way that handles uncertainty. We're targeting specifically the framework of conformal prediction to try and handle this problem. And so here the work would be performed both on public and private datasets in collaboration with DTA. Last challenge is batch pattern mining in industrial signals. So here the idea is to work on signals from industrial machines. And we have reference patterns that correspond to different programs that are executed by the workers using the machines. And we're interested in detecting those programs in a stream of signals, that through long-term monitoring, essentially being able to detect those references. The challenge being that we have perfect references, but in reality, since it's human operated, there are a lot of distortions of those reference signals. So we have to be able to detect them arbitrarily, including with very significant temporal shifts, delays, and so on. We have baselines already using classical dynamic time warping clustering approaches. And we're interested in developing state-of-the-art deep learning methods here. But obviously, since we have single examples, that's one shot. And so we can potentially explore data augmentation and various hybridation techniques with reinforcement learning or other, signal prediction architectures that exist out there. So that's all for the adaptive AI pillar. And of course, I'll be happy to answer any questions you may have as well. Thank you.
Thank you, Andon. We will move forward now to the industrial domains challenges, and hopefully we'll be able to go back then to the human-centric research pillar as soon as we have the responsibles in the call. In this sense, I'll give the floor to the manufacturing, and I don't know if it's going to be François or Inigo presenting this challenge. So Please, the floor is yours.
Yeah, I'm not neither Inigo or
Sorry, Christian.
or
Sorry.
Francois, but I can take this one. So if you just press 3 times, I think the text will pop up. So for this, it essentially would be to define some adversarial robustness metrics and trying to identify or at least determine what would be the most suitable threshold for these adversarial robust metrics, either that you have developed or identified, and that would be, let's say, applied to a specific system. So you can try to work up a methodology to identify these robustness thresholds for adversarial robustness. Yeah, so that's essentially the idea, trying to figure out what would be suitable for an AI system. How robust should that be against the let's say the robustness or at least adversarial attacks. So if you skip towards the IDM-M2, I think. Here we have some other part where I want to look at the bias aware in people detection. So essentially, there is this problem when you are developing a safety algorithm, trying to identify people. You are training that on a specific data set, and that data set might be biased or skewed to some extent. And here the problem is what would be trying to identify what should the optimal, or at least the feasible and optimal, let's say, deviation of these intergroups in these data sets. What should those be, and try to relate that to the MTTFD in relation to the ISO standard. So the MTTFD is a mean time to dangerous failure, which is a standard used to determine how safe is a system. So essentially trying to propagate this bias in the data sets and also inherently in the model to some safety aspects. That would be some of the ideas for this IDM2. And that was the very short presentation of those two. And I will go forward to the next and give the talk to Inigo.
Inigo, yeah. Thank you, Christian. Inigo, can you hear us?
Hello, everyone. Yeah.
Hello.
So I will be presenting challenge IDM3, explainable uncertainty-aware decision-making for AI systems in manufacturing. And the idea here is that the manufacturing industry has very strict performance requirements and quality requirements, which must be enforced and verified. And the problem is, if we use AI systems to control the production machines or the robots, then AI tends to be highly overconfident of its predictions, even in cases that it has not been trained on. So this means that we have a problem in that this can lead to errors, and which will lead to downtime, which would cost a lot of money. So we would like to be able to detect when the AI will commit these errors. We want to be able to quantify the decision uncertainty in the AI decision-making process, and then use this to provide guarantees on AI-based production systems. So scientifically, we are looking at one of the challenges is that there are no existing benchmarks for uncertainty quantification in manufacturing. There is also usually no ground truth uncertainty measures for manufacturing problems. In general, this is true for any uncertainty quantification in any context. And we are looking also at how can we explain the reason for a given uncertainty measure. So how can we communicate it to someone who is not an AI expert or a robotics expert, but someone who is an operator on the field? That means we need to develop some kind of user-friendly human-machine interaction framework that can communicate the meaning of the uncertainty in a task-specific way that an operator will understand. So basically, what is it that they have to adjust in the system to fix this error and get the production running again? In terms of research activity and the expected results, we will the candidate who takes on the challenge will be working on collecting a data set and creating a benchmark for uncertainty quantification. And we have identified some manufacturing and remanufacturing use cases. They will also be investigating methods for uncertainty quantification and explainability. So this could be everything from evidential deep learning, conformal predictions, ensemble methods, Bayesian neural networks. It's not necessarily predefined. They will also be working on defining a framework for training explainable and uncertainty AI models, uncertainty-aware AI models, specifically for robot manufacturing use cases. So this is an embodied AI challenge. And the output of this is expected to be the framework itself for uncertainty quantification, and together with some kind of user-friendly interface to communicate what this means to the end user, to the operator. We're expecting to be able to provide a robot demonstrator by the end of the challenge in a simple use case where we can demonstrate the technology, and to publish at least one conference paper and journal paper.
Thank you, Inigo. I will pass now perhaps to Walter. Can you hear us, Walter?
Yes, I can hear you now. Hopefully you can't see me, but most likely you can. I swear I have a schedule tomorrow with the barber. I'm sorry for the animations. Probably they've been mixed up while merging. Exactly, while merging the presentation, and probably there is also another bullet. But okay, more or less overall, what's this challenge about? It's about some kind of multimodal detection algorithm for the stress of the operators. So basically, the issue is that most of the stress detection algorithms are performed in a non-manufacturing environment, meaning for healthcare application or for office-based tasks. So nothing is on the shop floor. We provide a complete set. You can go to next slide. Yeah, again, same issue with the animations. Anyway, we provide a complete set of sensors where complete means EEGs, EMGs, ECGs, sensors for skin conductivity, and you can get the entire list in the text of the challenge. And we expect from the candidate, first of all, to take care, of course, also with our support about all the privacy-related issues, but mainly to develop some kind of algorithm working in this context, which will be validated in a laboratory environment through an assembly operations, so a real-like environment that we can provide. For what concerns the next challenge, again, this is basically a bit more free challenge. What we want to do is to replicate and inflect in manufacturing environment what is the Epic Kitchen dataset, and also to increase a bit, meaning to create an egocentric and multimodal dataset, eventually validated with some or validated with some algorithms for application, for example, for detecting the task that the operator is performing. For the next slide, again, with mixed up animations, but you basically are free to create the dataset, validate through some machine learning algorithm, and then to disseminate to the as an open source dataset. Both the challenges forecast the publication of the models in an open format, and both of them are subject to the publication of at least one journal paper. I mean, submission or the arrival to a ready to be submitted paper.
I take this opportunity to remind that for all the challenges, it's quite there will be a judgment on the dissemination plan. So I encourage all the candidates to take care about this aspect as well.
Thank you, Walter. We will
you, Anna.
move now, before going to questions, to the energy. This research pillar is led by INESC, and it is being proposed 4 challenges, as you can see in the screen. I will give now the floor to Manuel Pio Silva from EDP, who is proposing the first one. Manuel?
Okay, good afternoon, everyone, and thank you for being here. Thank you to InnovaMash Plus to organize this. This is a challenge from the, let's say, from the industry, and so this, although has this perspective of having contribution from academia, from research, has a practical effect on the industry because this is a very important or it's a big problem nowadays for the energy because we have a lot of renewables in the grid, and some of that energy becomes excessive in certain times of the day. And so we need to figure out if how we can use it and before going to the market, if there is a possibility or a probability to have this energy curtailed. Which we want to avoid. So the challenge here is to find the conditions if this might happen or not. If the bid is accounts for the risk also, because we need to let's say to decrease the time for the return on investment. And also, since we are talking about people that are not experts on AI, we need to find an agent or at least using LLM a way to interact with these humans, so that we can find from the knowledge existent in the industry what could be the use of this curtailed energy, batteries or industry or local consumers, something like that, that is evolving within time. So 2 models here that we want to use in this challenge. One that is predictive and the other is generative. And so the outcomes are there. We need to face humans here, and we need to find a bid that gets a return on investment as good as possible. This challenge, it's very critical for the industry for energy nowadays. If you solve this, you might get a Nobel Prize even. Just kidding, but this is becomes very important nowadays. And thank you, and I'll be waiting for your questions if there are any. Thank you.
Thank you, Manuel. Let's move forward to the second challenge within the energy, and I'll give the floor to Sajad from INESC. Sajad, can you hear us? I see that your microphone is not muted, but we cannot hear you. Okay, so perhaps while you try to solve your sound issue, I would perhaps ask Eduardo Veas from to present the other 2 challenges. Eduardo, you want to say something about these 2 challenges, ID3?
Yes, I can present the other 2 challenges. Sorry, I think you don't have the slides. I don't.
No, I don't. Sorry.
I noticed I don't have access. It was too late already, but I will send them to you, and you can integrate them for anyone who wants to read them.
Okay.
I'll tell you about the challenges. There are 2 challenges, and these challenges are connected to some of the challenges that were mentioned at the beginning because they deal with multi-agent systems for coding into one part, but it's a bit more comprehensive in the 2 ways, and also dedicated to the energy sector
data. So the goal is to simplify and clarify interpretability of this complex energy sector related data. There are new concepts for residential as well as for industrial users that are introduced with this large data collection of their energy consumption produced by smart meters. And these users will have to start working with this data, which was until now unimportant, and it's connected to their energy usage behavior. So the task that we foresee for this challenge is to develop a solution which will accept human prompts and questions for interacting with the data. So human prompts and questions about the behavior and data consumption, energy consumption, sorry. And then we'll prepare necessary algorithms and code to issue queries to one or multiple databases and data pools for smart meter data to extract the required data for the answers, then analyze the outcome and formulate the result in a human readable manner. So to do this, we foresee that we will have to deploy a multi-agent system and develop at least 3 components to facilitate this intuitive interaction with data using language prompts, an orchestrator component to decompose the prompts and assign roles to other agents and manage the workflow, a coding agent to generate the database queries, and then an interpretation sort of agent to analyze query results and formulate answers in a clear and understandable way for humans. There are some additional components that could be added, but these are the minimal expected outcomes. For the other for the last challenge, the second challenge is connected to this. One is it holds some similarity, but it's looking for more analytics task of possibly a domain expert that wants to perform analysis on the smart meter data. And in this sense, there will be a workflow and a chain of interactions with the data, which we usually try to formulate using visual analytics. Instead, what we would like to do again is to resort to a multi-agent system to generate code for querying relevant data on the basis of prompts that the expert defines what type of analysis and what type of comparisons he wants to have made. And as a result from the query, another agent will create code to produce visualizations and display them to the user. A possible add-on to this is also to prepare an explanation or narrative of the generated visualization explaining the main aspects of energy usage. So these are the two challenges.
Okay, thank you, Eduardo. I will ask Sajad if your microphone is already sorted out in terms of sound. Can you try it now, please?
Hi again, can you hear me?
Yeah, now we can hear you loud and clear. Thank you.
I apologize for the problem. And thank you very much for the presentation and organizing the workshop. So I will briefly go through this exchange scheme that we have at INESTEC. The main goal is to deal with the disturbances that is happening in the power system. This disturbance can be very small with maloperation of a circuit breaker, or it can be very in bigger picture, it can lead to a blackout. So the idea is to create basically reports in a fast manner for the system operator, using some graphics as well, so that it would be understandable where are the location, and basically to classify what type of disturbance is happening in the system. And also the key challenge would be that to balance basically the technical accuracy with the speed, and also in the dynamic environment of the power system. That would be one of the main challenges to deal with. And as I mentioned, LLM with background knowledge in the field of power system would be helpful to deal with this problem. Thank you.
Thank you, Sanjar. Again, if you have questions concerning this challenge presented within the industrial domain of energy, please use the Q&A feature in the chat. I will move now a little bit further to space and give the floor to Stelios that will be presenting the 4 challenges within this industrial domain. Stelios, can you hear us?
Yes, thank you, Anna. First of all the selected candidates will have the opportunity to join us here in Limassol at Cyprus at the Ravensthine Center of Excellence, which was established within the Excelsior Horizon 2020 TIMIC project. And we are currently employing more than 80 researchers. The first use case, Anna, if we can go to the next slide. The first use case, as I said, is about detecting potential water illegal abstractions using artificial intelligence and Earth observation. As we know, Mediterranean countries, as also Cyprus, part of the region, are suffering by water scarcity, and within this, we want to leverage spectral information from satellites to construct machine learning models and combine them with pre-trained models that we have at Eratosthenes in order to identify regions within the island that illegal abstractions of groundwater are taking place for a better water resources management. As output of this collaboration from the exchange scheme, it's one submitted journal article and one open access model or framework for potential water illegal abstractions detection. The next slide is about the next slide is about using double machine learning methodologies or causal machine learning methodologies on remote sensing proxies combined with meteorological data from open access datasets or datasets that we can create within this collaboration for the estimation of causal average treatment effect of different farming practices like fertilization, spraying application, irrigation management on yield productivity. Again, the expected output is a submitted journal article and a model or a framework. And we will give the floor to our colleagues from Danish Technological Institute for this use case.
Yes.
Is Miguel here? Yes.
Yeah. Can you hear me?
Yes.
Yes.
Loud and clear.
Perfect. Yeah. So my name is Miguel. I sit as a technology manager at Danish Technological Institute in our space section. And the challenge we brought with us is that the Danish maritime environment is dying. That's a shame. We would very much like to be able to monitor this. There's a great focus on this. Of course, not only in Denmark, but I just took one of the articles just recently written about this, as it's a major focus here. We see that high altitude balloons propose an exciting opportunity to do Earth observations on this, and compared to, maybe if I could get you to change the slide, yeah, compared to, as you see on the topmost image is a picture from Copernicus satellites, and down under we have an image from a stratospheric balloon on the same area, and because it's rather a bit closer, we can get a much higher resolution and more data streams. So we find it to be an opportunity to get more accurate readings from eelgrass, which is a good measure of how healthy the sea is. And we would very much like to know more about this and test this. So the outcomes of the project would hopefully be that there's a designed high altitude balloon sent up and tested to do some observations of eelgrass from a hyperspectral camera. Yep, that's it.
Thank you, Mikael. Then Stelios again. Back to you.
And yes, thank you, Anna. For the last use case proposed by us in the space task, we want to leverage and capitalize on existing small language or large language models to transform remote sensing and data into post-disaster response reports. And for this, with the selected researcher or research group, we will work towards having one fine-tuned model, one demo application showing the capabilities of such a combination, one submitted journal article, and one submitted conference participation for enhancing natural disaster response with artificial intelligence. Thank you very much.
Thank you, Stelios. Once again, any questions, please use the Q&A feature in the webinar. We are now going to move forward a little bit with how to apply to the open call, what are the eligibility criteria, and how the evaluation process is carried out. This fourth open call expects to grant 20 proposals at least, and the deadline for submission is the 31st of October, 5 o'clock in the afternoon, Brussels time. We expect the projects that are proposed within the open call to have a duration between 3 to 6 months. These are the minimum and the maximum duration. So when applying, you will be asked to clearly identify the period of your project. And we expect that the projects are implemented between January and June 2026. At the maximum, they could go until the mid of July, but it would be preferable if all the activities could be concluded by the end of June 2026. This open call is expected to attract proposals submitted by PhD candidates, postdocs, and senior researchers that are nationals from European member states or Horizon Europe associated countries, and that are employed or enrolled in PhD programs at academic organizations in European member states and Horizon Europe associated countries. Please note that researchers that are either enrolled in universities that are part of the consortium of ENFIELD, or researchers that are employed at research organizations that are also part of ENFIELD consortium, are not eligible to apply to this open call. The open call and the proposals can be submitted either individually or by a group of 2 researchers. In case the proposal is submitted by a group of researchers, please note that the group has to be composed by one PhD candidate and one postdoc or senior researcher. Submissions will be done exclusively via the link that you see there through the EU survey platform from the European Commission, and you will need to fill in all the mandatory fields of the form. You need also to accept the terms and conditions and present and submit a video presentation where you will be able to present yourself and your project to the reviewers. Again, I would like to highlight the deadline for submission, the 31st of October, so within 1 month and a half, you have still time to prepare your proposal. In terms of the application form, okay, you will be asked initially to identify clearly if the proposal that you are submitting is either an individual proposal or if it's being presented by a group of researchers. In case of a group of researchers, we will be asking for the identification of who will be the group leader, if it's either the PhD candidate or on the other side, if it will be the postdoc or senior researcher. Okay, in here you will have, of course, to indicate your name, your nationality, your date of birth, your position, and also the CV in if necessary. Then in the previous open calls, we had an annex that had to be uploaded. This open call is different. Everything is done online, so there are no technical annex to be added. You should present all the project details directly in the online application form. For this, you will be asked to clearly identify to which challenge you are applying to, and then all the evaluation will also be made against to what is expected for that challenge. You will have to suggest a title for your proposal and present the abstract. There are 4 technical fields that you will have to fill in that I will show you exactly what we intend. So in terms of the proposal abstract, it will be important that you mention what are the main objective and expected result of the exchange scheme that you are proposing, what will be the activities, and of course, because this is being funded by the European Commission, what is the European added value that your research will bring on. In terms of the novelty of the proposal, the contribution to the state-of-the-art advancement, in this case, you need to identify into what extent your approach will be beyond the state-of-the-art, what is the innovative aspects, what is new that you are proposing. This would be the 3 areas that will be assessed by the reviewers when reading this section of your proposal. Then the scientific approach, it will be important for you to clearly describe the methods and methodology that you will be implementing, and also what kind of resources you will be leveraging on. As mentioned before by technical partners, dissemination and communication is also a key aspect within this exchange scheme program. So therefore, you should present how will you do the dissemination of the exchange scheme, about the research itself, its results, but also against the collaboration with the ENFIELD network. And at last but not least, of course, it will be very important for you to explain the competences and skills that you have in the field of research that are crucial for the successful achievement of the project that you are suggesting. Please note that each field has a limit of characters, okay? And they will not allow you to go beyond that limit, so please be sure to be concise and concrete in your presentation. Then, in terms of video submission, okay, you cannot upload the video itself, okay? You will be asked to add the URL of the platform where you are hosting the video. You can use YouTube, Vimeo, or other platforms that you select. Nevertheless, please note that the video should be accessible without requiring any login or password. Okay. In case to access the video, reviewers have to do some kind of login or registration in any kind of platform, the video will be considered non-eligible, okay, and this can jeopardize the proposal as a whole. In terms of evaluation process, initial eligibility verification will be done by Innova to filter out and discard non-eligible proposals, and those that are non-eligible will get a rejection letter with a justification. Be aware that no additional feedback on the process will be given to those proposals that are not eligible. In terms of those that fill in all the eligibility criteria, they will move on to the evaluation phase, and this will be done remotely by 3 senior researchers from the ENFIELD partner scientific organizations, and then after the remote evaluation, they will be convened into participating into a consensus meeting where all the decisions on final score and selection will be made. All the rejected proposals will receive, of course, the letter and evaluation summary report, and those that are selected, and I recall that we expect to select 20 proposals within the open call, will be asked and invited to proceed with the sub-grant agreement preparation in order to start the implementation of the project, as mentioned also earlier, in January 2026. Okay. In terms of the remote evaluation, this, as I mentioned, will be done remotely by 3 senior researchers from ENFIELD partners, and they will be basing their analysis on the 4 evaluation criteria that are clearly detailed in the guidelines for applicants. This entail advanced state-of-the-art, scientific approach, dissemination and communication, and technical and creative capacities. So, in fact, each one of the criteria aligns with one of the fields that you are required to fill in when preparing to the proposal. Each evaluation criteria will be scored between 0 and 5, where 0 means that the applicant has failed completely in addressing the criteria, and 5, it addresses in an excellent manner. The final score, including for each criterion, is the average of the 3 evaluations provided by the 3 senior experts. The threshold for each criterion is also 3, and therefore the overall score threshold is 12. This indicates that if a proposal scores less than 3 in any of the criteria, or the overall score is inferior to 12, the proposal will be automatically rejected. Please also note that in terms of the advanced state-of-the-art criterion, we will be giving it a weight of 1.5 to determine the final ranking of the proposals. Then after the ranking, there will be some rules in order to place the proposals that might have the same score, and there are 5 rules, as you can see on the slide. The first rule, proposals with a higher score in criteria 1 will be put it first. If then we have still proposals with the same score, we will put first those that have a higher score in criteria 4, and then if still tied, priority will be given to those proposals that have relevant social and environmental impact. Okay. Finally, if still needed to have some kind of criteria to anti proposals that are led by women or with a gender balanced teams will be prioritized in the final ranking list. Okay. The consensus meeting, as I mentioned, it's expected to come out with the final ranking list of the proposals and to determine which of the proposals received will be selected and proposed for funding. It is expected decisions to be made by consensus, but whenever consensus is not possible to be reached, a majority vote of 2/3 will be used to determine the final decision. And this is the presentation in terms of procedures. Meanwhile, I noticed that we have already online the representatives of the Human-Centric research pillar, and therefore I would invite them to present briefly, very briefly, the sorry, there are too many slides. It's better to do it like this. The correspondent challenges. So Adina, Astik, I see you both online. Welcome to the webinar. Can you hear us?
Hello. Yes,
hello,
I can
Adina.
hear you. Sorry for not being in time. I do apologize. So I'm going to briefly present you now the challenges in human-centric AI. The first challenge is empowering human AI decision-making through real-time user modeling. The gap is the fact that AI systems don't model user cognitive states such as confidence, load, decision style to adapt their behavior. Therefore, we have the key questions: how to infer latent cognitive states with limited data, how does adaptive AI affect trust and performance, and how to measure trust to generalize to real use. The research scope of this challenge is cognitive modeling, eye tracking or psychological sensing, behavior experiments with domain experts, and new user models, trust metrics, or adaptive systems. The overall vision towards this challenge goals is to enable human AI teams to outperform either alone or together through real-time user understanding. Next, please. The second challenge is called interpretability and uncertainty in predictive models. It is about increasing demand for models that are both accurate and interpretable. Post-hoc explanation often lack fidelity, and uncertainty quantification is key for trust of users and safety of applications. Therefore, there is a need for integrated frameworks combining interpretability and uncertainty. For example, conformal prediction, which enables uncertainty-aware explanation. Therefore, one of the tasks in this challenge is to apply such a model to tasks like time series forecasting, anomaly detection, classification, and some other to be discussed with the host organization. And of course, as in any other challenges that you have already listened to, a publication in a top-tier AI conference or journal. Next, please. The third challenge is human-centric explainable AI for critical digital infrastructure. Critical infrastructure operators need to be able to trust AI solutions for monitoring, security, and reliability. We know that today we face with big opaque models which hinder adoption and real-time explanation, especially in the case of multivariate streaming time series data. And this is still a challenge. In this project, you may follow one of the following tracks: explainable anomaly detection on telecom KPIs data streams, or concept-based interpretable forecasting to improve service reliability, or benchmarking methods such as sharp line integrated gradients for intrusion detection models. Again, publication at top-tier conference or journal. Next, please. The fourth challenge is human-centered causal machine learning for real-world decision support. The integration of causal machine learning, very shortly called CML, with explainable techniques is currently a challenge. Then for the focus of this challenge is to generate counterfactual reasoning over images, to provide personalized, explainable insights based on causal reasoning to end users in critical sectors. And one specific focus of this challenge is agriculture. And therefore, the topic must design a model to ensure scalability and generalizability of causal machine learning models to handle large data sets, for example, Earth observation, but to handle this across time and spatial scales. This is a challenge that will be developed in collaboration with Eratosthenes Center of Excellence in Cyprus. And of course, the results should be reported in a top conference or journal. Next, please. Well, the last, not least, challenge in human-centric AI is explainable AI methods for human AI decision-making. There is still limitations in the interpretability of transformers. And here is an example, video action transformer network. So the focus of this challenge is to design or adapt Xi methods for dynamic spatial temporal models, to align explainability outputs with the expectations of end users, and to identify which types of explanations are most useful and most relevant in a specific context in real-world decision-making. And of course, this should be instantiated in a demonstrator user case in at least one application domain. And here is the example of human action recognition, but some other use case can be selected. And results should be published in a top conference or journal. Thank you.
Thank you, Professor Adina, for being so concise and straight to the point. We appreciate it. We have now the question and answer session open, and we are willing to receive questions from the audience. We received one already on the chat concerning does the grant cover institutional overheads? Please note that the exchange scheme open call grants 2,400 euros per month as a mobility allowance for the researcher that is engaged in the project, and therefore it works as a mobility allowance. It is not foreseen to cover institutional overheads or support costs related with other researchers of the affiliated entity from where the researchers are coming. I don't know, Ingrid, if I answered your question, but I hope so. Are there any other questions from the audience? Feel free also to unmute your microphone and pose the question, if it would be easier.
And there is a question in the Q&A.
Okay. I plan to submit my PhD thesis at the end of October with a final defense scheduled for April 2026. Could I confirm, could you please confirm if I'm eligible to apply to this for this call? You will have to apply as a PhD candidate, okay? But it is important that the situation, let's say, is continual concerning the period of the exchange scheme. And in that sense, what I would propose, if feasible, would be that your exchange scheme would be proposed for a period of 4 months, because it seems that you are planning to have the PhD defended by the end of April. So this would give you like a project of 4 months. Okay. I have also Gani with a hand raised.
Yeah, hi. Thanks so much for all the provided information. Might have a specific question concerning the adapting AI challenge. I could see that there are a lot of sort of approaches that are proposed for the proposal. For instance, from like a continual learning LLMs till hardware level optimization. Would be proposal accepted for multiple subjects, or just one would be selected, I'd say.
I'm not sure the question was for Andong. Can you repeat the question, please, Gani?
Yeah, so basically I could see that for the adapting AI challenge, there are multiple subjects suggested for work. And the idea that I think for each challenge, there is only one accepted proposal. That's the idea, no? Or multiple ones.
It can be multiple ones. We have
Okay.
a number of researchers that we want to fund that are 20 within the open call. Then we will assess the best proposals for each one of the research pillars and also for the industrial domains. But it can happen that more than one challenge has a selected proposal.
Okay, thank you so much. So it doesn't need to be sort of inclusive for all the directions, but probably one of them, like one.
No, you have to select a specific challenge, okay, and focus on one specific challenge.
Okay, thanks a lot.
Okay. And other questions? The slides and the recording of the webinar will be made available on the project website and on YouTube. Okay. Ingrid, yes, it is expected that at least a portion of the exchange scheme, okay, is held at the host organization. That is why the open call grants a mobility allowance. So please consider that it will be required some time spent at the host institution of the project. Okay, the host institutions are also described in the catalog of challenges. At the end of each challenge, you are able to see who from the ENFIELD network is hosting the challenge, and that probably will be the host also of the project. Okay. Amra, I think I answered your question concerning lots of challenges. Does it mean we have to work on a specific field of one of the challenges? Yes, you should present a proposal that answers directly to one of the challenges that we are publishing within the open call. Okay. The grant SAFA is provided to the researcher that is implementing the project. The grant is not aimed to fund the supervisors of the researchers engaged in the exchange scheme. Okay. Any other questions? Again, we also have our general web page on the open call. There you can find also the contacts to to where you can send additional queries if they come alongside when preparing your proposals. These questions can be either technical in terms of the challenges or more administrative in terms of submission procedures. We will be mediating the questions together with the technical responsible for the challenges and try to clarify them as swift as possible. Please note that it can take some days for you to get an answer, but we'll always try to answer all the questions that we receive concerning the open call. You can also access all social media challenges of ENFIELD Network through our website, so we invite you also to visit the website. If there are no further questions at this point, and because also we are reaching the time planned for this webinar, first I would like very much to thank you all the technical partners that made themselves available to present the challenges today. And of course, many thanks also to those that are participating and that are interested in the open call. We look forward to receive your proposals and we remain available for any clarification that you see as needed. I wish you all a very good rest of day and we'll be in touch. Have a nice day. Thank you for joining.
Thank you, Anna. Thanks, everyone.
Thank you. Bye.
Bye.
Bye-bye.
Thank you. Bye-bye.